Problems dealing with distance, rate or speed, and time are called motion problems. To translate them, we will use the basic motion formula, rate times time equals distance. And I've set up a table in anticipation of solving this motion problem. Let's get to it. On her bike, Allison travels 10 miles per hour faster than James does on his tricycle. In the time it takes Allison to travel 3 miles, James travels 1 mile. Find the speed of each. So let's fill in the table with the information that is given here, and we'll put James and Allison down to keep track of the information. It talks in this first sentence about Allison's speed being 10 miles per hour faster than James' travel on his tricycle. So the key here is James's speed, if we only knew that, and that's where we'll start with our variable. We'll let x represent James' speed. Allison then is traveling 10 miles per hour faster, so we'll take James' speed and add 10 to it. The next sentence tells us in the time it takes Allison to travel 3 miles, so we'll record that. Her distance is 3 miles. James travels 1 mile, so we'll put our 1 mile distance there. And it's saying that the times are equal for these two to travel these distances that were given in the problem. Using our formula then, rate times time equals distance, we have the formula RT equals D. If we solve for time, we'll divide both sides by R, and we end up with time then is equal to distance over rate. So to fill in our time column, we'll do exactly that with the values that we have. Our distance for James is 1. We'll divide that by his rate, which is x. Likewise, Allison, her distance is 3 in a rate of x plus 10. And to set up our equation then, it says in the time of Allison's travel, it equals James' travel. So that will be the basis for our equation then. So James's travel time equals Allison's time. And we'll put in those values that we have found here from the table. James's time is 1 over x. Allison's time is 3 over x plus 10. We have a rational equation. Because we have a ratio equal to a ratio, we can use cross multiplication to eliminate our rational equation in this example. Otherwise, we could multiply by the least common denominator. So let's go the easy route by using cross multiplication, product of the extremes. So I'm going to take 1 times x plus 10, which is x plus 10, and set it equal to the product of the means. X times 3 will represent as 3x. By using cross multiplication, we've eliminated our rational equation. Now, to simplify and solve, subtract an x from each side, leaving 10 on the left and 2x. Dividing both sides by 2 leaves us with an x is equal to 5. Going back to the table then to see what x stood for, x is the value of James' speed. So he's traveling at 5 miles per hour. Allison is x plus 10, so if we replace x with 5 that we found for a solution and add 10 to it, then Allison's speed is 15 miles per hour. And we've solved and answered the question then, finding the speed of each. James 5 miles per hour with Allison at 15 miles per hour.